Hello everyone. In this session today we are going to cover a very simple but important process called the Haber process, which is used for the manufacture of ammonia gas. Okay. Now, why do we need to manufacture ammonia gas in the first place? Ammonia has several uses. It is the most important one that we can remember is manufacture of nitrogenous fertilizers such as ammonium nitrate, ammonium sulfate. But it also has a few other uses. It is used in removal of greasy stains, softening hard water, and manufacture of nitric 5 acid. So we just need to know one or two so that when asked we can answer them. Now we go to the actual manufacturing of ammonia gas. The ammonia gas, how do we know the raw materials for preparation of ammonia gas? It's just from the gas itself, nitrogen and hydrogen. So nitrogen and hydrogen are what are used to prepare ammonia gas. Now an important question that can be asked is nitrogen and hydrogen, where are they coming from? Nitrogen is coming from fractional distillation of air, where nitrogen distills off at minus 196 degrees Celsius. Okay, and hydrogen can come from a couple of ways. We just need to know one or two again. The first one is cracking. We won't write everything, just listen to what I'm saying. Cracking. What is cracking in organic chemistry? Cracking is the breaking of long chain alkanes to shorter chain alkenes, and sometimes hydrogen gas. So hydrogen gas can come from cracking, or it can come from electrolysis of brine. Electrolysis of brine. What is brine? Brine is concentrated sodium chloride solution. So in electrochemistry, when you electrolyze brine, you can get hydrogen. So that is where hydrogen is coming from to manufacture ammonia. Secondly, what is our next step after we produce nitrogen and hydrogen? We are going to purify the gases. So when we purify the gases, we remove impurities, dust particles, and arsenic compounds. Why are we purifying the gas? Yes, to prevent poisoning of the catalyst. And what is the catalyst that is used? Well, we will come back to that later. So after purification, to prevent poisoning of the catalyst, we are going to compress the gases. Compressor means bringing the molecules closer, increasing their pressure. High pressure of 200 atmospheres is used. In the contact process, we saw that pressure of only 2 to 3 atmospheres is used to make the process economical. But in this process, the Haber process, 200 atmospheres necessary. Why? High pressure, first of all, increases yield of ammonia by shifting equilibrium to the right. And also, it brings the molecules closer for faster reaction. From the compressor, the ammonia and hydrogen are going into the heat exchanger. What is the condition in the heat exchanger? Temperature of 450 degrees Celsius, just like we saw in the contact process, 450 degrees Celsius. What are the roles of the heat exchanger? Let us mention them again. The first one is preheat the incoming gases. In this case, the incoming gases are nitrogen and hydrogen. Cool, the second one, cool outgoing gases. What will be the outgoing gas? Ammonia gas. And it gives the heat the necessary temperature required to maintain the reaction. Okay, that's the role of the heat exchanger. Now, the heat exchanger is sending gases into the catalytic chamber. Which gases are those? Nitrogen and hydrogen are going into the catalytic chamber. In the catalytic chamber, nitrogen and hydrogen are reacting to form ammonia gas. Okay, so nitrogen and hydrogen reacting to form catalytic chamber. Now, that's the fun part. What is the catalyst that is used? Finely divided iron, or you can say finely divided iron coated with aluminium oxide promoter. So the iron is Fe or aluminium oxide, the two catalysts that can be used. Okay, that's the catalytic chamber. Now, what reaction is occurring in the catalytic chamber? Well, nitrogen is now reacting with hydrogen to form ammonia gas. Nice, sweet, and simple. Nitrogen reacting with hydrogen to form ammonia in the catalytic chamber. So if nitrogen and hydrogen came in, which gases are going out? Ammonia gas. Going back to the heat exchanger, where it is cooled. Now this is still hot ammonia gas. Now it is being cooled. Cool ammonia. Why are we cooling the ammonia? Why are we not just letting it go the way it is? We are cooling the ammonia to prevent its decomposition back into nitrogen and hydrogen, because here the reaction is reversible. If favorable conditions are present, the ammonia can decompose back into nitrogen and hydrogen. From the heat exchanger, the cool ammonia is then condensed to form liquid ammonia. Ammonia collected as a liquid for easy collection. So that's it about the Haber process. Let's make a very fast recap. Nitrogen and hydrogen. Nitrogen from fractional distillation of air, hydrogen from cracking or electrolysis of brine. You purify the gases to remove dust particles, arsenic compounds to prevent poisoning of the catalyst. You compress the gas, pressure of 200 atmospheres. You take them into the heat exchanger, temperature of 450 degrees. From there you go into the catalytic chamber, where the catalyst is finely divided ion. Nitrogen reacts with hydrogen to form ammonia. Ammonia then goes back to the heat exchanger. It is cooled to prevent decomposition back into nitrogen and hydrogen. From the heat exchanger, they go into the condenser to condense the ammonia, and ammonia is collected as a liquid. Now the yield here of ammonia is 10% only. So what happens to the 90% of the hydrogen and nitrogen that were there? They are recycled, and they go back to the initial process and start again in manufacturing ammonia. Some few physical properties of ammonia are: 1, it is a colorless gas; 2, it is very highly soluble in water. In fact, it is the most soluble in water. 3, it is a basic gas. It is the only gas in chemistry that you will come across. It is basic. A gas being basic means that it changes moist red litmus paper to blue. Okay, it has a pungent smell, a pungent choking smell, and it is less dense than air. When a gas is less dense than air, what do we directly conclude from that? It is collected by upward delivery. That's what we will see when we cover the laboratory preparation of ammonia and other chemical reactions that ammonia can go through. So that is it for this session. I hope you understood. If any questions, drop them in the comment box and I will be happy to explain. Thank you so much for watching. If you like my channel, show some love, subscribe and keep watching. Thank you so much.